Well, let's get started. First of all, thank you so much for coming. There are a couple of seats here in the front, so you don't have to stand the whole 45 minutes. Usually I do this talk in an hour, and usually on the way here my demos work. But this morning my laptop decided to reboot, reinstall some stuff, and everything went to hell. So pray with me that my demos will work. I really did my best to get everything up and running again, but you know, your mileage may vary. So who here is a software developer? Yeah, lots and lots of you. Have you ever been in a situation where you needed to deploy your software to production and you know it ends up somewhere over there? But you needed to know about everything that came with it. So you need to have a place to run your compute. You need to have some place to store your data. And you need to know how to keep everything up and running in a secure manner, which is, well, quite daunting. Today I will show you how Radius can help you work around this problem. But first, let me please introduce myself real quick. My name is Loek Duys. I live here in the Netherlands. I work at Xibia as a cloud architect. And what you are about to see is a glimpse of the future, of course. This is about the future of cloud-native software development. The downside of it, we are in today, and I'm going to show you the future, so stuff will break. I'm using pre-release software, which is Radius. It's all 0.4 something. And yeah, it's just likely that stuff will break. I really did my best to keep everything rock solid, but yeah, forgive me ahead of time. So the agenda for today is I will show you about Radius concepts. So what is it? What can you do with it? Why is it convenient? I will do lots of demos, hence the stuff that will fail. I will first deploy a very simple app, gradually add complexity to it, ending up with something which could be considered a production-ready app running right there in the cloud. But first, if you want to predict the future, you need to have a look at the past first. So, about 25 years ago, we started with, well, I started my career building monoliths. So everything was in one solution. It was relatively easy to understand. However, if the monolith breaks down, then your whole system is down, of course. So we started doing services-oriented architectures with the intent of reusing stuff. Well, we did it wrong, so we ended up with a distributed monolith, which is just using more services who are tightly coupled. At the same time, we were starting to do DevOps. So the intent here is to increase the velocity of the team, quicker time to market. But all of a sudden, we needed to learn how to get stuff into production. To deal with the SOA issues, service-oriented architecture issues, we started doing microservice architecture, in which we separate by functionality instead of by technical verbs. However, running all these services increased the complexity for the team, because now they need to know how to run all that stuff. Don't worry, we started using containers to run all that stuff. Which increases the likelihood of your packaged code to, if it runs on your machine, it will probably also run somewhere in the cloud. But now you need to learn how to run containers efficiently at scale. We started doing cloud-native software development, which can really increase your velocity. By using cloud services, you don't have to build and run everything yourself. You can just focus on what's important to you. But now you need to know which cloud service to use in what scenario and how to keep it secure and compliant. Finally, a little relief in the form of platform engineering. It aims to make your life as a software developer or a product team just a little bit easier. So finally, something that decreases your everyday complexity. A downside here, of course, is that you need an engineering platform to run all this. And this is where Radius comes in. So Radius is a platform engineering tool. So you have an IT for IT team that runs this tool for you, and it makes your life as a member of a product team that much easier by offering you these golden paths into production. Radius was built by Microsoft originally, but now it's an open source project, so it's part of CNCF, and everyone here can contribute their own code to it. Radius also aims to be cloud neutral, so Azure will be prime citizen there, but they also have AWS support, and even Google Cloud support is on the roadmap. So the aim of Radius is to reduce the cognitive load for product teams. It does so by offering these golden paths to the production environment. It also offers something called an application model, which can be used to talk about your software. So instead of looking at either software itself or a list of resources in the cloud, Radius gives you an application model, which enables you to have a discussion between people who do operation stuff and people who do development stuff. Radius runs your application somewhere, and it can also manage this application environment it ends up in. And don't worry, if it doesn't make sense yet, I hope it will at the end of this talk. Right, so quick overview of the elements that make up Radius. So it's mostly focused around an application. It offers a few tools for you as a developer. It offers a few tools for operations-minded people. You can even do it in one team, of course, doesn't matter. It also has support for different application lifecycle stages. So your application evolves from a test environment to a production environment, and that is fully supported as well. And finally, it offers you an environment for your team as well, so you can work either in collaboration with other teams or in isolation. If you look at Radius running in production, you will see that it has these building blocks. So you can have stuff like containers that you can define. You can have state stores, you can have messaging components, and it's all abstracted away, like the details you don't have to worry about. You can just add them to your app and start using them. The most important feature is recipes, which are infrastructure templates. And don't worry, again, I will show it in much more detail later on. So Radius by itself is an application platform. It runs on Kubernetes. So you install Radius somewhere on a Kubernetes cluster, and then it exposes some APIs, which you can then talk to using a CLI. So RAD is the CLI for Radius. And what happens if you do RAD commands, it can start applications on that same cluster. So Radius runs on Kubernetes, but it also operates on Kubernetes. Your application will end up in that cluster as well. And of course, your application will be defined by something called an application model. All right, so probably most of you here have at some point in your life seen this, which is a bicep file. But I bet you haven't ever seen these resources before. So instead of storage accounts, you now see these concepts: applications core, applications, containers, that sort of stuff. So this is a bicep file that is targeting Radius. So let go of everything you know about bicep. Now it's the way to talk to Radius. Right. The cool thing is, if you use this kind of an approach, you can also talk to Azure itself, so it doesn't hamper you in any way. You can talk to Radius, you can still talk to Azure or Azure AD, but you can even also talk to Kubernetes using a bicep file. All right, so for any production-ready app to end up in production, you will need to pass a few milestones along the way. So this is my roadmap to production. So of course you need to think about compute, where to run your API, for example, or your front end. You need to talk about team isolation, so where can a team develop outside of the real world, or maybe collaborate with other teams and integrate. You need to have these application lifecycle environments, test, maybe acceptance and production, that sort of stuff. You are probably going to need some kind of a state store, like a storage account, Cosmos DB, whatever. And maybe there's interaction in an asynchronous manner that requires messaging. Of course, these things need to talk to each other, so we need to have networking support there as well. And you need to end up in a production environment which is fully secure and compliant. We will cross off this roadmap one by one. So first, let's talk about compute. Well, we've already seen an application definition before, and the most essential part of compute is, of course, running a random container. And this is what you see then in your application model. So it targets some image which is somewhere in a OCI compliant registry, Docker Hub or your Azure Container Registry, whatever you prefer. And then Radius can make sure to run this application for you. So what happens in reality, it will just spin up your container on Kubernetes somewhere. So we can cross off the first list, first item from the list, and now start talking about how teams can collaborate. Well, your application will always be part of an environment. And in Radius, there is this verb called, a noun called environments, which is just a way to work, to put your applications in. So as you can see on the right-hand side, you will have that container, and maybe that container talks to a database. And in order to get that running somewhere, it needs to be part of an environment. Again, test environment, production environment, whatever you want. Your application also needs to be part of something called a resource group. Now, you may know this term from Azure, but this is not an Azure resource group. This is a Radius resource group. And the intent here is that probably you are part or a member of a team, and this team wants their own environment. So in your mind, imagine this is the test environment. So you will have a team that has access to a resource group. They will have an environment that is called test, and they will run their application in that environment. The cool thing is, in the future, this will also be a security boundary. So stuff running in resource group 1 cannot see stuff running in resource group 2 by default, which gives you a nice isolated way of running stuff in your test or production environment. But then we already talked about, well, Radius runs on a Kubernetes cluster. Which one? Well, this is what the workspace is for. So a workspace really ties a resource group to a given cluster. So you can have as many resource groups running on as many clusters as you want, mix and match, that's all fine. But you need to have a workspace in order for the CLI to know where to deploy your application. So a workspace is tied to a single resource group. You can have multiple workspaces on one cluster. And it's also important that you realize that a workspace is just something on your machine saying, well, if I talk about the test workspace, I mean this cluster over here. So there's not a concept within Radius, it is just a concept to set the CLI straight on where to deploy stuff. All right, so enough talk for now. This is the exciting part where I do my demo. I really want my demos to work, so I built a script runner tool. So I started on the left-hand side, and then it executes on the right-hand side. And the nice thing is I can use my clicker to execute commands. These are real commands. It's not a movie that you're seeing, but I don't want any typos because I don't have any time for that. I'll make sure that I am in my application working folder, and now I can do CLI commands like red workspace list, which lists all the workspaces that are known on my machine. So you can see a cloud workspace and a local workspace. Well, you can already imagine the local one is running on my local Kubernetes cluster, and the cloud one is running in Azure. I'll make sure that I'm targeting the local workspace because the next stuff I'm deploying, I want it to end up on my local Kubernetes cluster. So I need a resource group for my team, which is a team. I need, well, to inspect if it's all correct, just to show you what the CLI can do. And now I need an environment. So this is running locally, so I'll name this environment test. And now the final step is to deploy my application, and this will take a while, and that gives me time to explain about this file that I'm deploying, app.v1.bicep. Right. So this is an application model definition. So my application consists out of a single container, which you can see on the bottom here. My app needs to be defined itself. So whenever I deploy this file, this contains the name of my app. The environment also needs to be present. There's nothing fancy about it here yet. And this is my application. So I'm saying, well, please deploy this demo application that the Radius team has created for me. And then once it's running, make sure I can access it over port 3000. Now, usually I've talked long enough now for this to complete. Yep. And you can see that deploying this app by using red run, it has created the application and also created these tunnels, port forwards, from my machine to my cluster. So it doesn't matter where this cluster is, as long as I can deploy stuff to it. I can also create network tunnels, so I can now talk to my workload running on that cluster. So let's try and do that. Oh, that's, sorry, should not have done that. I hope it deploys quickly. So the end situation here, get rid of all these windows. You can see I did a lot of testing in the speaker room. Localhost 3000. Yes. So this is my single container running at port 3000. So it's not very fancy at all because it's just one container, doesn't have anything attached to it yet. But when we come back to this demo next time, it will be a little bit more exciting. And what you also saw was that there was a port forward made to localhost 7007, which is the Radius dashboard. So if I want to have a look at my application that I just deployed, I can just go and then check it out and then see this amazing app graph, which has this single container. Again, this is a little bit too simple, but imagine at the end of this talk, when we deploy a proper app, this can actually be useful. And now I can do Control-C. Make sure I'll delete this app because I want to be ready for the next demo. Right. Okay, so we have a failing clicker. Yes, that's interesting. We can cross off team isolation and team collaboration because we can use these built-in Radius concepts for it. So now let's think about how we can move from our local development laptop into maybe an integration environment in a really nice way. So we probably are going to need a little bit of state storage with our API. So we were just running a single container, and I want that to be maybe a container and a data store attached. If I am a developer, well, if I'm running on my local laptop, I don't really care what makes up my, my state store. I just want a state store to be present. But if I put on my operational hat, then I want this state store to be fully compliant with corporate policy. I want it secured and encrypted and everything. And I don't really care about the software that runs on it. So these two perspectives, they are nicely put together in Radius by abstracting away the details. So if I run this situation on my dev laptop, I can have one state store. If I run it in the cloud, I can have a totally different state store. And the trick here is using Radius recipes. So you can see a recipe on the right-hand side. So consider this an infrastructure template that has a type. So whenever I say state store, in one scenario, it will be a container running on my machine. And in another scenario, it can be Cosmos DB running in Azure. And the content of the recipe will determine the concrete implementation of my state store. So as a developer, I don't need to worry about what my state store really is. So there are a couple of rules you need to follow. So a state store needs to have a resource type. So Radius knows what we are actually deploying using that template thingy. It needs to have a few return values. So for example, if we're deploying a state store, I probably want the connection string to resolve from it so I can use it in my app. And I need to publish this template to an OCI compliant registry somewhere. So it can be used anywhere on the planet. So the one downside of recipes here is that you do need a little Kubernetes expertise because, well, at the end of the day, you are going to run a container on Kubernetes. This recipe needs to be able to do that. Unless you deploy to the cloud, of course. Right, so as a developer, it's quite easy to use these recipes. I can just say, well, I am in my test environment. I want to use these and these recipes. probably stuff that runs containerized. And then in my app, I can just say, well, please use a recipe by this name. And then I don't really care what's in it. Well, there are a few types you can choose from. So it's not just about state stores. There's also support for messaging. There's RabbitMQ queues, for example, can be used for pops-up messaging. And for anything not covered, right now you have this extender type, which is just run this thingy for me. I don't know, I don't care. And in the future, again, farther down the road, Radius will support these things called user-defined types, which allows you to add types to this list, which are not built into the product. All right, so if we look at our roadmap now, we have a pretty good grasp. We can do compute, we can do teams, we can do test environments and production environments. And now let's see if we can maybe improve on that whole usage of state stores. If I deploy a state store somewhere, I probably want to access it from my application. It probably has a connection string. And this connection string needs to be passed down to my app so it can connect to that state store. Well, Radius has a feature for that as well. It is called connections. And there's nothing magical about them. It just creates environment variables with a fixed name and passes that to the container that is your application. So if your app knows how to read those environment variables, then it can use them and connect to the store. Well, again, not just talking, let's see that for real. And that would mean starting my second demo script. All right, make sure I'm in the right folder. So I will do red deploy again, but then app v2 instead of app v1. And I will show you the differences here, not here. So app v2 is slightly different from the previous one because it adds this thing called a Redis cache to the mix. So all the other stuff is the same. And now I'm also deploying applications data stores Redis cache. And I name the recipe default. Of course, I need to make sure that the default recipe is there as well. And this is the definition of my recipe. And for those who understand Kubernetes at all, this should make some sense. So I have a Kubernetes deployment, Kubernetes service, and I output some information about the connection string so my app can use it. Don't worry about the details, but my app does understand that. So in my app, I can say, hey, I know that there's a Redis cache deployed somewhere down the line, and make sure you have a connection to it. And this will make Radius inject those environment variables so I can connect. If everything has worked well, I should now have a deployment here. Yep. I can make one of those tunnels manually as well. In the previous demo, I did a red run. Now did red deploy. The difference is I don't get the tunnels by default. So this is me creating one of those tunnels myself. And I did it again. But now I have the command in my history. So if I now go here, keep an eye on this no connections defined. This was the previous version. If I refresh, and now all of a sudden it has a state store. And it knew that it had a state store by the connection being present and these environment variables being present. Which is kind of nice. I'll leave it with that. Right. Okay, make sure to delete this thingy. Back to the slides. All right. Well, we've now seen an app that talks to Redis in both scenarios. I'm talking to Redis on my local machine using a Redis container, and I'm talking to Redis somewhere else, maybe by using a cloud service. Wouldn't it be nice if I could get an abstraction in between? So I just want a state store in my app, and I don't really care about the actual implementation of it. And this is where Dapper comes in. So, well, you probably heard of Dapper at some point already, But Dapper is a really nice CNCF project, and one of the most powerful features that it offers is that it can provide a layer of abstraction between your application and services that it uses. So for example, PubSub messaging or state store, many different other things. I can talk to Dapper API to get stuff done, and Dapper will know which concrete implementation of the service I want to use to target that. That means that my application doesn't need to be aware of where it's running at all, and I don't need to change a single line of source code to move from one environment into the next. If you haven't heard of Dapper before, do have a look at it, because it's becoming a real nice project. So if you look at Dapper in combination with Radius, it is a fully supported system. So stuff that you can use within Radius also has Dapper support. And that means that you can create these nice recipes for Dapper state stores, for example. And don't just take my word for it, because I have a nice demo for it. I do need to terminate the previous one. Get the right demo here. Okay. Right, move to the right directory, and now I will deploy app.bicep, and again show you what it contains. App.bicep here. So this is a slightly more complicated app, so it has a few moving parts. For example, it has a front end and a back end, and probably the back end will use some state. So I decided to nicely put these things in separate files. So I have a front end file and a back end file. This is just basic bicep functionality here. If I look at my back end, it will have a container that offers that runs my API. And instead of a Redis state store, I have a Dapper state store. And that means it's abstracted away what the concrete implementation would be. And of course, it makes a lot of sense in that scenario to use a recipe instead of a concrete implementation. So by simply swapping out the recipe, I can target a concrete implementation of my Dapper state store. I think I talked long enough. Yep. I will create some port forwards. Yes, that's not going to fly, but I can change the port number. Okay. Creating a lot of port forwards. And now that's the downside of scripting everything. So this is the Dapper dashboard. So any good OSS tool nowadays comes with a dashboard, of course. So Radius has a dashboard. Dapper also has a dashboard. So by deploying this dashboard into your cluster, you can have a quick look at your application, which is really nice, especially if it comes to these the logging here. So you can see the telemetry flowing from your application. Have a look at it to see why it may or may not function very well. But this seems to be working nicely. So I can now also open the Dapper store itself and maybe place an order. And the fact that it didn't crash here and show an error message means that Dapper is happy and it is using my my state store, which is kind of nice. And then now, if I look at my application model in the Radius dashboard, it's already becoming a little bit more complicated. So you can see maybe not a backend that is connecting to a state store, and you can also see a front end that is not connecting to anything because it runs on my in my browser. Terminate some port forwards and delete this app. Hopefully it frees up some ports. Okay, well, we now know that by using Dapper in the mix, we have a really nice way of swapping state store and messaging components when moving from local development environments into production. Kind of cool. Now we need to worry about networking, and that means the traffic coming into my app on the front end. I need to make sure that that ends up at the right container. Imagine you have an API in the front end. You probably want to direct some traffic to the API. You can do pattern matching for that. So if I use this gateway component, I can say, well, all HTTP requests that come in that have /API in it, well, forward them to an API. If it has hub in it or dispatch hub in it, forward it to the API because it's my signal R endpoint. And anything else, please send it to the front end because it's probably a request for the front end. This is just an example. This is not something you have to do, but this explains the concept. So this is where the gateway resource comes in, and it's sort of a reverse proxy that looks at your requests and makes sure that it ends up at the right workload. Right, so this is the more complicated app. So on top of everything, you have a gateway that takes in the user's request for data. It decides where to direct it, either to the front end to show HTML or to the back end to get JSON from it. You can also see I'm running a second system there, which is the plant API. There's no traffic directly from the front end to the plant API thing, because this is an internal back office system, and I only want it to allow communication through internal messaging. Well, this is again just an example of everything that you can do with Radius. So I don't want to talk to any concrete implementations, so I made Dapper abstractions for everything in the middle. So I'm not talking to my MongoDB directly, I'm talking to Dapper, and Dapper is talking to Mongo. Don't worry, in the next couple of slides it will become obvious what the benefit here is. So for all the telemetry, I'm using Jaeger, which is a really nice open source hotel collector that comes with a dashboard, so I can really see what's going on within my dashboard. What's going on within my cluster. Right, so it's important that you realize that all the stuff I've highlighted there is the applications stuff, and it doesn't need to change when I'm moving from one environment to the next. And the stuff I've highlighted below, that is the stuff that will change for every environment I deploy to. So my test environment deploys containers, and then my production environment may choose something else. So I will now deploy that entire application. Make sure I'm finished here, yep. Oh no. Right. Make sure I'm on my right workspace, and deploy an environment first. So what I failed to mention before is that these recipes, they are tied to an environment. So right now I'm deploying my test environment. I have an infrastructure as code template for that. And in this environment, I will say, well, this is my test environment, and I want you to use recipes to be found here and here. So I'm running containers. So the second step would be to deploy my application to that environment. And the magic is here. The -e test means I want to target that environment that I just created. While this is running, I can show you the actual files that I made. So my app, it is kind of complicated. I'm using modules, I'm using recipes. This is like the production environment the production ready system I'm deploying here. So it is all nicely separated into different modules. You can see front end, plant API thingy, dispatch thingy, a couple of parameters, and something called shared. So there's a shared module as well. Let's start with that. So these are the shared services like messaging, open telemetry collection, that sort of stuff. So this is what I will deploy first. So shared services are there first, and then I can, for example, deploy my dispatching system, which is an API. It has a state store. You see a little bit of leaking abstraction here. Please ignore that. Probably will be gone for GA. So apparently my dispatch API container has 3 Dapper state stores, which is already very nice. And then because of the magic here, I'm using local recipes. I can say, well, if you want to deploy open telemetry container, use Jaeger for that, which is a container. If you want to do PubSub messaging with Dapper, please use Redis for that. And for a state store, I can use MongoDB, for example. So, cool thing is, my ops people created these recipes for me. So really, my application, it doesn't need to worry about it. It just says, well, I have a recipe, it has a name, just deploy it and I will use it. So I don't need to know anything about how to deploy Mongo, for example. I think I talked almost long enough. What else can I say? Oh, maybe go to the front-end resource. So this is the gateway. Well, it's very similar to the picture I showed you in the slide. So I've made these routes that make sure that the traffic coming into my app will end up at the right place. And I'm also using HTTPS certificates, so my connection will always be nicely encrypted. Yeah, that was long enough. So I'm now using a gateway, so I don't need to worry about doing all these port forwards anymore. So that saves me from having to do all that nasty mapping stuff to get to my app. But well, I do need port forward to get to my extender, because it's it's not a Radius thing, it's an extender, so Radius doesn't know anything about it. So I'm using a Kubernetes hack to find my Jaeger container and create a port forward to it. And then create one for the Radius dashboard as well, but not for my app. So if I want to talk to my app, I can just use curl on localhost. Well, this is the good news we were all waiting for. So my API health endpoint, it's now reporting that it's healthy, and that gives me a good feeling that I can probably also open a browser and go to localhost dispatch. Right, okay. So you don't need to know anything about this app, because that's a totally different talk. I won't bore you with any details. But what you should know is that whenever everything works, we get a blue pop-up message there. Right, well, really exciting. But what happened? What really happened was my front end talked to my API. My API sent a message to that plant API thingy that did some processing in the background, sent a message back when that was done. API, dispatch API received the message, and then you signal R to get back to the front end. And you think, well, that's a lot of steps. Stuff can probably go wrong somewhere along the way. Well, and this is where Jaeger comes in. So this is my telemetry dashboard. And just to see if everything went well, I can do stuff like, I need to zoom out to see the message type I'm interested in. Right. I can select different operations here, different services, so everything in my application is visible here. And then I can do this, find traces. I send one message, and this is really nice because you can see I was not lying. So the dispatch API did a message, and then the plant API got the message and sent the message back to the API. So all this telemetry just for free. Just the fact that I'm using Dapper and containers on my Radius environment and run something that listens at a given endpoint, all this telemetry just started flowing for free, which is nice. All right, let's have a look at the Radius dashboard. So I won't zoom in too much, but you can already see this has become quite a complicated system. And as a developer, this makes it just that much easier to talk to other people about my app. So I'm not looking at sources, not looking at lists of resources in the cloud. I'm really talking about my application here. You can talk about the dotted lines, which are the connections between them. So if you really want to know what's going on within your functional domain, this is a really useful dashboard. One of the key features that Radius offers versus other engineering platforms. All right, let's kill some stuff. And I'm not going to delete that one. It takes too long. Because we need to get ready for the last demo, of course, which is the greatest one. All right, so last item on the list is the production environment. We've seen the networking in action now, so we're confident we can take this into production. So, same system as before. So the moving parts in the top area, all the same. I don't have to change a single line of code in my app. I just need to say, hey, Dapper, whenever you talk to state stores, please use this component. And then I need to make sure myself that these components are in fact available somewhere in the cloud. And of course, I do that by using recipes. So, top level doesn't change, bottom level does change. So I've put them side by side here. So it's important to realize that whenever I run dev test, I use these things as implementations for my Dapper messaging, state stores, and telemetry. And then whenever in production, I'm using Azure resources, Azure services as a proper implementation for my production environment. And of course, instead of using a container for all my telemetry, I'm using Azure Application Insights, which works even if I don't have my machine turned on. Right, this is the moment we've all been waiting for, of course, the demo that deploys to production. Yeah, should be fine. Clear. Okay, so of course, to do this, I need to switch my workspace because I'm no longer talking to my local cluster. I want to switch to my cloud cluster, which is Azure Kubernetes service running somewhere in the cloud. And then I need to make sure that my resource group is there, my A-team resource group. I need to make sure my production environment is there. I do that using infrastructure as code, of course. That's the first line. So my environment is here. My environment contains recipes that create Azure resources instead of local containers on Kubernetes. And if all works well, the next line should deploy my application itself. So not much has changed, but instead of using containerized resources, I'm now using cloud resources. And I thought I'd just show you a couple of those. And these should look well, kind of familiar. So this is probably what you are used to see. So this is just a regular bicep block, bicep resource describing a Cosmos DB account. If you ever created one of those, that's just exactly the way you would do it in the old days. But of course, this will be sent to Radius first. Radius will see, hey, this is an Azure resource, and then start talking to Azure on your behalf to create it if it isn't there yet. Well, then you need a couple of more resources, and when that is done, we can create a Dapper component, which says, okay, I am a state store component, but if you call me, then you need to talk to this Cosmos database. And that's what you see happening here. And then, of course, we need to output the connection details to the application. And this is kind of nasty, so pretend that never happened. All right, I think maybe I talked long enough. Yeah, oh, this is the demo guards again. Doesn't matter, just in your mind, imagine it went well, because I did this at home. So I can call my endpoint anyway, even though the deployment failed. I did it at home already. So I can now open the app for real. So this works on all your machines as well. So if you go to demo.lookd.com, well, you get a login screen. So you can't mess with my demo. But if I submit this, and stuff appears on the top right corner here. That means that instead of using all these containerized resources, I'm now using Azure resources everywhere. And if time permits, I do know it's 1 o'clock, but I can take 2 more minutes, right? Cool. That means that I can now open these cool things on the Azure portal and see, well, this is something that takes a little bit of time, but yeah, that's too bad. So if you wait maybe 2 more minutes, then you should see a request flowing in here, proving that I am in fact using this Azure Service Bus instead of RabbitMQ locally. I can also open my Cosmos database account and see that data has been put into it. Right. So my plant state now exists. So my plant API uses this state store to store stuff. That's the stuff. And finally, I can use my application map within Application Insights to show you, again, yeah, stuff is happening here as well. So this is all the telemetry flowing from my application, being collected and forwarded to App Insights. And now I can see my app telemetry in the production environment. Nice. Okay, everything can be crossed off. In the future, Radius will be much more rock solid and help you get into production very soon. And if you want to know more, if you have any questions about anything, please get in touch with me. Please give me a rating on this preview website as well. And well, come see me after if you want. That was it.